This C# console application code will demonstrate the selection sort and bubble sort algorithms. So this console application is designed to just execute without any user input required. And it has two arrays that have been pre-populated to demonstrate these two common sorting algorithms. So let's just take a quick look at the code here. So we have our main method, and the only thing significant in this main method here is that we pre-populate two arrays. So here's one array called the selection sort numbers array, and I've just added 10 random integer values, and they're all out of order. Here I've got the bubble sort numbers array, and it has again 10 elements with random set of integers in a different order. So the idea is we're going to step through these, and the way we do that is in the main method, all we do first is just display out to the user so that they can see the original array that's out of order that we're going to demonstrate the selection sort algorithm, and then I execute the the selection sort algorithm by a selection sort method that I've created down below. And all I'm doing by calling that method is I'm passing the array into that method, and we'll look at that here in a bit. And then I display with a for loop here the values in the bubble sort numbers array to the user. And then I execute a method called bubble sort and pass the bubble sort numbers array to that method, and then display the sorted version. So for each of these, first you display the unsorted version, and then you run a method that executes the algorithm, and then you display the sorted version of the array after it runs the method. So that's all we have here in the main. And then so let's look at how that works, and then we'll look at the algorithms and the two methods we provide in this code. So I'm just going to run this console application, and so this is what we see. This is the original version of the array that we're going to execute the selection sort algorithm, so it's all out of order. And then after execution of the method that runs the selection sort algorithm, you can see that all of the integer values are now displayed in order, in ascending order. So we've sorted those, and then we display another array that's got different values, and they're all out of order, and we demonstrate the bubble sort algorithm with that array. So we execute a method that runs the bubble sort algorithm, and you can see that it then ordered those integer values right here, sorted those out in ascending order. So that's how this application works. So we've got two methods to observe in this code. The very first method here is this selection sort, and then of course we got the bubble sort. Now the primary difference between the selection sort and the bubble sort, the selection sort, what it does, what it's designed to do is it starts at the very beginning of the array, and it attempts to, each time it starts at the beginning, it attempts to identify the lowest value as it runs a whole sweep through the array. So it finds an element each time it goes through from all the way from the beginning to the end. It checks to see, okay, is this value less than that value? If it is, it sort of holds it in a temporary as you'll see below, it sort of holds it into a temporary location, and then once it goes through all of the steps in the array, it then has the element within the array that holds the lowest value, and from that it will swap with the last value that it evaluated. So in the very first run on the array, it would be the first element. So it would swap the first element with the element in the array identified that's lower. So it would swap that, and then it would go back to the beginning but start at the next element instead of the very first one. At element 0, it would start at element 1, second element. And it would do the same thing again. It would attempt to identify the lowest one, run a whole sweep, and store the lowest one, and then conduct a swap with the current location within the array that it started the second sweep from. So it just continues this so that as it gets to the end of the array, it will have swapped the minimum value that it can find within the array. So that's the select. It selects the minimum value in the array and then conducts the swap. So what we've got, we do have a nested loop. So big O notation here has a bit of an expense with the sorting algorithms. They are a little expensive. So this one would have its degree of complexity, of time complexity, would at least for big O notation can be as bad as O notation with n squared. And so the advantage that this has, let's say, in the selection sort is that it never makes more than a single swap. So it just, as it goes through, it just locates that min value and makes that one swap and doesn't come back to that spot again. Whereas you'll see in the bubble sort, it goes back to the beginning and starts over and over and over again until they're sorted. So anyway, that's what's interesting about the selection sort. So here we start this sort algorithm, the selection sort algorithm, by having a value to hold the min position to keep track of the element. So we want to keep track of that one that's the lowest. And we want to then have this temp variable that we can use to begin swapping once we've completed a sweep through the array. So we have those variables handy. We then start in on a for loop so we've passed in the selection sort. We have an array, an integer array that we declared up above that was passed into this, and you saw up here when we run the select sort method, we're going to pass it this selection sort array, these numbers here. This is what we're passing, an array with those values. So let's come back down here. So that's where that gets passed in here, right there in the method as an argument. So we interrogate the values of that array using the selection sort algorithm by first looping through those values. And again, we're going to keep track of that low minimum value, the element that contains the lowest value in each sweep. So what we're doing here is from the minimum position that we locate, we check to see if the next element is smaller. So each time we start from the first element we're interrogating in the array, and that becomes our lowest at that moment. And then we check to see, okay, is it less than, is the next one less than that one? If it is, we get that, check that position, we mark it as the minimal position, and then down below right here, what we're looking to do here is conduct the swap if we find that the current position that's being evaluated in the loop, in other words, the next position is lowest, then we can conduct the swap or the switch. So that's really what we're doing here. We just interrogate right here. We keep track of the lowest one. We enter into an iterative for loop and interrogate the current position and see if that's any lower than the one that we're keeping track of, that we put sort of aside. You might call that sort of a secondary or a sub array, might be better described as. So this sub array, and it just moves along and says, hey, is that value less than what we've got sitting here? oh, okay, it's lower, okay, get that value and put it in there. And so as we go through that, then we can begin to swap values and put them in order down here. So that's what we're doing. So if you can imagine just something that slides through the array over and over until it exhausts the end of the array, and conducting a swap each time we sweep, and going to the next element within the array each time it goes through an iteration. So very efficient. Now let's go here and take a look at bubble sort. Now what bubble sort is going to do, instead of like selection sort where we're selecting the lowest one and carrying it with us, and then not starting over from the very first element of the array each iteration. So we've already determined, okay, yeah, in this whole array that one was lower, so let's replace it in the beginning, and then go to the next element and run all the way through and find the lowest. Instead of that, with bubble sort, we sort of start over and go from the beginning each time and check, okay, hey, is this one lower than that one? Oh, if it is, swap it. Okay, go to the next one. Is that one lower than this one? It is. Okay, swap it, and then exhausts every element within the array and starts over again. And it just keeps going and iterating until it can no longer swap a lower value from the one before. So each time starting over from the beginning and sort of popping a bubble and saying, hey, okay, I found one, and start it over again. So it pops each time, pops the bubble. So bubble sort. So again, we bring an array in the bubble sort method. We interrogate that array with a for loop. We also have an inner for loop. So our O notation, big O notation, is O n squared. So there is an expensive cost here as well. Now it is possible to perhaps build a better method, a better, more efficient version of this bubble sort, where we may be able to get it down to O n, where perhaps we deal with it right here inside this if condition. Maybe we could make this area a little more efficient, but I think for demonstrations of bubble sort, this is a very common way of approaching this algorithm. So once we start with the outer loop here, we're looking at and interrogating it again. We have another inner loop, and then we check the if condition each time. So the nested loop, within the nested loop, we're interrogating to check to see if the next element value is lower than the current one. And if the element is less, then we can conduct the swap right there in the if condition. So again, and then once we do that swap, we sort of go through every element within the array, swap them if needed, and then start over again, and then swap, and then start over again, and then swap, and just keep swapping if the next value is lower than the other one. And that's the bubble sort. So this C# console application again demonstrates using code the selection, sort, and bubble sort algorithms where no input would be required from the user. It's just going to automatically execute against two pre-populated arrays.